Assalamu alaikum dear students. I am back with another informative video. Today we will be discussing alkanes in detail. So let's get started. First of all is the basic introduction. What are alkanes? Alkanes are saturated hydrocarbons which consist of single covalent bond between carbon atoms. Now what are alkanes? Alkanes are saturated hydrocarbons. Hydrocarbon means these are the compounds made up of carbon and hydrogen atoms only. Now what is meant by term saturated? Saturated means that they consist of carbon to carbon single covalent bond in them. For example, methane. Its molecular formula is CH4. It consists of one carbon atom and 4 hydrogen atoms. So, as there are 4 valence electrons in carbon atoms, so carbon uses all of its 4 electrons and form 4 single covalent bond with 4 hydrogen atoms to make one molecule of methane. Similarly, all alkanes uses their carbon atoms in the formation of single covalent bond. Each carbon atoms makes 4 single covalent bond by using all of their 4 valence electrons. Now, the general formula for alkanes is CnH2n plus 2, where n represents the number of carbon atoms. Now, homologous series of alkanes. Like all other classes of organic compounds, alkanes also form a homologous series of compounds. So, now in the first column we will write down the number of carbon atoms. 1, 2, 3, 4, 5, 6 and 7. We will be discussing first 7 members of the homologous series. Now, the name of the hydrocarbon or alkane with respect to the carbon atom present in it. Now, the first member of the alkanes homologous series is, for one carbon atom, meth is used as the prefix, and the name of an alkane end with ane. So, its name will be methane. And what will be its molecular formula? By using general formula, we will derive its molecular formula. CnH2n plus 2 is the general formula. Now we will take the number of carbon atom as 1 here, C1. H will be 2 into 1 makes 2 plus 2 is 4. So the molecular formula for methane is CH4. Next, for 2 carbon atom, eth is used as the prefix. The name will be ethane. Its molecular formula will be C will be 2 and H will be 2 into 2 makes 4 plus 2 makes 6. Its molecular formula will be C2H6. For 3 carbon atom, prop is used as the prefix, so its name will be propane. For its molecular formula, we will take C as 3 here, and hydrogen atoms will be 2 into 3 makes 6. 6 plus 2 is 8. So the molecular formula for propane will be C3H8. For 4 carbon atom, but is used as the prefix. Its name will be butane. For molecular formula, we will take 4 as carbon atoms, and for hydrogen atoms we will multiply 2 with 4. 2 into 4 is 8. 8 plus 2 is 10. So the molecular formula of butane will be C4H10. For pentane, molecular formula will be carbon will be 5 and hydrogen will be 2 into 5 is 10. 10 plus 2 is 12. Molecular formula will be C5H12. For 6 carbon atom, hex is used. So the name of an alkane with 6 carbon atom is hexane. its molecular formula will be C6H. 2 into 6 is 12. 12 plus 2 is 14. C6H14. For 7 carbon atom, hept is used as the prefix. The name will be heptane. And its molecular formula will be C7H. 2 into 7 is 14. 14 plus 2 is 16. C7H16. So, this is the homologous series of alkanes for the first 7 members. So, now we will see that there is a difference of CH2 group between the successive members of the homologous series. Like in between pentane and hexane, there is a difference of CH2 group and a mass of 14 units, as carbon has a mass of 12 and hydrogen atom are 2 here, so it makes 14. So there is a difference of CH2 group between the successive member with the mass of 14 units. Now all the alkanes are made up of carbon to carbon single covalent bonds. This means that they undergo same type of chemical reactions. They show similar chemical properties. But as all the alkanes have different masses, so they show different physical properties, and there is a gradual change in the physical properties. Gradual means that a regular trend or a pattern is followed. No ups and downs are present while when we go from one alkane to another alkane. There is a regular trend that is followed. So now we will do a question. Question is, derive the formula of an alkane with 12 carbon atoms. So we will use the general formula of alkanes, that is CnH2n plus 2. N will be 12 here, so its formula will be C12, and hydrogen atoms will be 2 into 12 is 24. 24 plus 2 is 26. So the formula of an alkane with 12 carbon atom is C12H26. Okay. Now I will use this table to explain the molecular formula, displaced formula and structural formula for the first 5 members of the alkanes homologous series. So the first member of alkane homologous series is methane. What will be its molecular formula? First of all, we should know that what is the molecular formula. Molecular formula tells us about the actual number of atoms present in the molecule. Actual number of atoms of every element present in a molecule. And what is the displaced formula? Displaced formula tells us about the bonds present between the atoms, and through these bonds we will be able to see the arrangement of atoms in the molecule. And the structural formula gives the arrangement of atoms in a compound. So for methane, the molecular formula is CH4. Its displaced formula will be carbon will be taken in the center and it will make 4 single covalent bond with 4 hydrogen atoms. And its structural formula will be CH4. Now ethane, its molecular formula is C2H6 and its displaced formula will be, first of all we will draw 2 carbon atoms and then satisfied all of their 4 bonds by using hydrogen atoms. Now, what will be its structural formula? For this, I will number the carbon atoms in the ethane. I will start numbering from the left side. So this will be the carbon number 1 and this is carbon number 2. So I will write the first carbon here. How many hydrogen atoms are attached with this carbon atom? There are 3 hydrogen atoms. So I will write 3 hydrogen next to the carbon atom, CH3. Then I will write the second carbon atom, and with second carbon 3 hydrogen atoms are also present. So I will write hydrogen as 3 here. So its structural formula will be CH3CH3. Next is propane. The molecular formula for propane is C3H8. I will draw a chain of 3 carbon atoms and then satisfied all other bonds of carbon atoms with the hydrogen atoms. You will see that all carbon atoms form 4 single covalent bonds. Its structural formula will be, again I will do the numbering here. I will start numbering from the left side, 1, 2 and 3. So first carbon atom is attached with the 3 hydrogen atoms. I will write CH3. Then second carbon atom is attached with the 2 hydrogen atoms. I will write CH2. And for the third carbon atom, it is also attached with 3 hydrogen atoms. So its structural formula will be CH3, CH2 and CH3. Now next member is butane. C4H10. For displayed formula, I will make a chain of 4 carbon atoms and satisfied all other bonds with the hydrogen atoms. There must be 10 hydrogen atoms in the displayed formula. So its structural formula will be, I will start numbering from the left side. With the first carbon atom, how many hydrogen atoms are attached? 3 hydrogen atoms, 1, 2 and 3. So I will write CH3. Then second carbon atom, it is attached with 2 hydrogen atoms. Then third carbon atom, it is also attached with 2 hydrogen atoms. And the last fourth carbon is attached with 3 hydrogen atoms. So its structural formula will be CH3, CH2, CH2, CH3. Now the last is pentane. Pentane is C5H12. First I will draw the chain of 5 carbon atoms and satisfied all other bonds with the hydrogen atoms. There must be 12 hydrogen atoms in the pentane. Now I will draw its structural formula. Its structural formula will be, first carbon atom is attached with 3 hydrogen atoms. It will be CH3. Second, third and fourth, they are all attached with 2 hydrogen atoms. CH2, CH2, and for the fourth carbon it is also CH2. And the last fifth carbon is attached with 3 hydrogen atoms. So this is the structural formula for the pentane. Now we will discuss the physical properties in detail. The first physical property is the physical state. First 4 members of the alkanes homologous series are gases at room temperature and pressure. This means that methane, ethane, propane and butane, C1 to C4 carbon alkanes are gases at room temperature and pressure. From pentane till alkane with 16 carbon atoms, they are liquids at room temperature and pressure. Higher alkanes are solids. This means that from pentane C5 to hexadecane with 16 carbon atoms, they exist as liquids. And from alkane with 17 carbon onwards, they exist as solids. So, as we go down the homologous series, with the increase in the number of carbon atoms, the forces of attraction are getting stronger. So, the compounds changes their state from gases to liquids and liquids to solids. Next physical property is the solubility. Solubility follows the principle of like dissolves like, which means that polar substances are dissolved in a polar solvent and non-polar substances they are dissolved in the non-polar solvents. As alkanes are covalent in nature, which means that they don't have positive and negative ions in them, they are non-polar, so they are dissolved in non-polar solvents, which includes organic solvents like hexane, carbon tetrachloride, benzene, toluene. So they are insoluble in polar solvents like water. Other physical properties like melting point, boiling point, flammability changes with the chain length. Chain length refers to the number of carbon atoms in a compound. Next physical property is melting and boiling points. So, as alkanes are covalent compounds, so generally they have low melting and boiling points because of the weak intermolecular forces of attraction present in them. But as the size and the mass of the molecules increases, their attractive forces between them also increases and more energy is needed to separate them. This means that with the increase in the number of carbon atoms, the trend is that melting and boiling point increases down the homologous series. Next physical property is density. Density is mass per unit volume. It is directly proportional to mass. This means that with the increase in size and mass of the molecules, they become heavier and their density increases. So the trend is also increases. Next physical property is viscosity. Viscosity is fluid's resistance to flow. Fluid's resistance to flow. Larger alkanes have greater forces of attraction between them, and also the large molecules get entangled into one another, so it becomes difficult for them to flow. Their viscosity increases, so the trend is also increases. Next physical property is flammability and combustibility. It is the ability of an alkane to burn. With the increase in the chain length, means that with the increase in the number of carbon atoms in the compound, the percentage of carbon is increased, so they become less flammable. They burn with great difficulty, or when they are burned they produce more smokier flame. Their flame is more sootier, which means that their flame consists of unburnt carbon particles. So the trend is that flammability and combustibility decreases with the increase in the number of carbon atoms down the homologous series. Next and the last physical property is the volatility. First of all, you need to understand what are the volatile substances. So, substances that have the boiling point just above the room temperature, they are volatile in nature. This means that their particles have much energy to evaporate or change their state from liquids to gas at room temperature and pressure. So, as the increase in the number of carbon atoms in the alkanes, the forces of attraction become stronger, and it becomes difficult for the molecules to get evaporated due to increase in the forces of attraction among them. So, volatility decreases with the increase in the number of carbon atoms. Now, note down the key point here, that the trend in all the physical properties like melting point, boiling point, and viscosity, and next is density, they all increases with the increase in the number of carbon atoms. But flammability, combustibility, and volatility, their trend is decreased with the increase in the number of carbon atoms. So this is all about the physical properties of alkanes.